Good day everyone, my name is Dayang Nursyafiqa Nabeela from Group 5 and I'll be presenting the project planning and scheduling for the KLIA Aerotrain restoration project. The Aerotrain started in 1998 and connects terminals at KLIA, but in early 2023 it began facing serious breakdown. One major incident stranded over 100 passengers and the service was shut down. Now in 2025, the full replacement system is still in progress but not yet ready. So this project focuses on a temporary fix to restore service as soon as possible. I'll begin with the planning process. Project planning is the first and most important step. It helps us decide what needs to be done and how to manage everything properly. First, we set clear objective, which is to repair the Aerotrain, ensure safety and start operations while waiting for the full system to be ready. Then, we created a work breakdown structure or WBS. This divides the project into smaller tasks like inspections, repair, testing, and final approval. We also listed the team members needed, such as engineers, technicians, safety officers, and project managers, and matched them with the right tool and equipment like rail grinders and diagnostic system. The estimated budget is around 22 million Malaysian ringgit, which covers labor, replacement parts, tools, and communication needs. Finally, we also considered safety, communication, and the social impact, making sure the public is informed and that the repairs cause minimal disruption. Once the plan was ready, we developed a schedule using a Gantt chart that runs over 21 weeks. We use the critical path method, which helps identify which tasks must be done on time to avoid delays in the whole project. In the first week, we started by identifying stakeholders. By the third week, we completed the planning and got budget approval. In week 4 to 6, we prepared for the repairs and finalized the scope. Then, we started procurement to get the required parts. Repairs began in week 9, followed by system setup in week 11. From week 12 to 14, we focus on safety inspections and a trial run to make sure the system worked properly. Then we did a performance review followed by final quality checks and finally monitoring the enclosure in week 20 and 21. This schedule helps us manage time, assign resources, and stay prepared for risks like part delays or weather issues. It ensures we can restart the service on time. In summary, both project planning and scheduling are crucial in restoring the KLIA Aerotrain before the full system is completed. Planning helps us organize everything, such as tasks, people, tools, and budget. Scheduling helps us stay on track and avoid delays. Together, they make sure the temporary fix is completed smoothly and efficiently. Thank you. That's all from me. Moving on to the next presenter.
To respond to the root cause of suspension of KLIA Aerotrain, HR have implemented a relevant human resource strategy. This includes who they want to hire for the project, for example, internal and external engineer. Not only that, when they want to hire the personnel, either in testing phase, in quality check phase, and etc. In this workforce planning, it shows how many personnel required to run the project. For example, electrical engineer required 3 staff. They can hire either internal or external. This external source indicate a skilled person who can simplify complex problems. To ensure a precise task delegation, the table below show the hour schedule and working schedule rule. It shows that before, during, and end shift schedule, where all personnel need to obey the provided schedule. However, to optimize the work process throughout this project, time and motion method analysis is proposed. As indicated in table below, one of the optimization method is by task segmentation, which it will reduce total cost project time by enabling simultaneous operation. Next one is performance assessment. A multi-level performance evaluation structure are proposed to ensure the accountability and continual improvement throughout the KLIA error trend repair project. Within the multi-level performance, daily task check, weekly review, and KPI tracking is suggested to ensure comprehensive monitoring. And not only that, a clear documentation and quantitative metrics are also implemented to measure performance objectively. For HSE practice, a zero tolerance safety policy is aggressively implemented to protect the crew safety and the continuity of airport service during the Aerotrain repair project. These include daily safety protocols, for example, toolbox meeting, mandatory PPE, for example, wearing helmet, emergency preparedness like mock drill for a fire situation, and the last one is environmental measure for quality control purpose. Next is supply chain decision. The supply chain strategy for KLIA Aerotrain repairing project adopt a dual sourcing such as local and international supplier. Local supplier are utilized for fast moving parts such as a wiring. On the other hand, international supplier are engaged for the specialized part, for example, sensor. Effective risk identification and action plan are crucial in ensuring the project proceed without avoidable disruption. For example, if some of the aerotrain part delivery delays, they can tackle the issue by maintain a buffer stock for a critical component. This will reduce impact of variable lead time. Next is inventory management. A well organized and data driven inventory management system is vital to maintaining uninterrupted material flow and preventing delay during project. To achieve this, ABC inventory classification method is used. Category A is critical components such as sensor. Meanwhile, category B and category C is moderately important and a low cost but high frequency material. Second is first in, first out or FIFO, which is ensuring all the stock is utilized first to maintain the risk of component degradation. Last part of mind is advanced technology. And adoption of modern technology play a crucial role in improving transparency. During the project, a high value component can be tracked using FRID or barcode system. Last but not least, cloud-based inventory dashboard provide a real-time visibility into stock level and issue automated low stock alert for future purchasing.
Hello, my name is Jesse Darren, and today I'll be presenting on my part, which is project controlling for our project, which is the KLIA Aerotrain upgrade. So as you can see, there are 7 key points here, which is the performance monitoring, applying cost variance, schedule control, recognizing risk, develop risk mitigation strategy, propose monitoring methods. There's like 4 of them, which is for the resource, the cost, the quality, and also time, and also finally the feedback approach. So for the first one, which is the performance monitoring and progress tracking, we use earned value management, as we could call it EVM, to track the progress by comparing planned work, complete work, and actual costs. This helps us to spot issues much more earlier. And then for the second one, cost variance shows that if we are over or under budget, a positive value means that we are saving money, and a negative one, which is overspending. The cost performance index, or as known as CPI, tells us how efficiently we use our budget. And then for the next one, which is the schedule control, the schedule variance and schedule performance index SPI shows that if we are ahead or behind schedule. This helps us to adjust plans to stay on track, which we could do from our Gantt chart. We could modify our Gantt chart so that we could rearrange our roadmap, our milestone. So for the second one, sorry, for the next one, which is the recognizing possible risk and effect, we identify risk like technical problems, contractor delays, and safety concerns. We assess how likely they are and their impact on the project. And then this relates for the develop risk mitigation and strategies and contingency plans. It relates to the previous one, which is that to reduce risk, we work closely with equipment experts, enforce contractor standards, conduct through thorough testing, and keep everyone informed. We also set aside extra time and budget as backup. And then the next one, propose monitoring method or process. There are four of them, which is the resource, cost, and quality and time. I'll go through it generally. So basically, for resource monitoring, we track daily and weekly weekly resource use to make sure labor and equipment are properly allocated and avoid all delays. So for cost monitoring, weekly reviews compare actual spending to the budget. We forecast future costs to prevent surprises, unpleasant surprise, I might say. So for the quality one, a regular inspection and third-party audits ensure that the work meets safety and quality standards, which you could heard maybe OSHA or something, and any problems are fixed quickly as soon as possible. And then for the last one, which is the time monitoring, we use Gantt charts and critical path analysis to track tasks and deadlines. We monitor buffer time to handle delays without affecting the final date. And finally, the last point, which is the feedback approach, we hold regular meetings with stakeholders, collect passenger feedback, and use incident reports to quickly address issues. So, in summary, in short, by closely monitoring cost, schedule, quality, and risk, and keeping communication open, we aim to complete the KLIA Aerotrain upgrade safely, on time, and within budget, ideally. And so, for the quality management, there are seven of them. For the total quality management, I suppose there are seven concepts. First one, the customer focus, and then next one, leadership, employee involvement, process improvement, supplier partnership, and continuous improvement. And last one is the system approach. I will go it one by one, but as simple as I can, which is for the first one, customer focus. It gather feedback from passengers and staff to improve services and meet expectation. For the second one, it ensure top management provides supports and resource and empowers team to lead quality efforts. For the third one, which is the employee involvement, it forms teams from different departments, provide training, and recognize contribution to keep employees engaged. And then for the fourth one, analyze current processes, find inefficiencies, and use tool like root cause analysis for continuous improvement. For the fifth one, the supplier partnership, it chooses reliable suppliers, regularly evaluate their performance, and build strong cooperative relationships. And then the sixth one, which is the continuous improvement, it holds improvement events, benchmark against best practices, use data to guide decision. And for the last one, which is the system approach, it integrates all functions, maintenance, operation, and customer service to work together and continuously improve. That is all for the quality management.
Good day everyone, my name is Sabin with matrix number BK22110284. Today I'll be presenting our comprehensive strategy for handling the Aerotrain repair project for Malaysia Airport Holding Berhad or MAHB at Kuala Lumpur International Airport. Given the urgency complexity of restoring the Aerotrain services, our team focused on selecting the right process, strategy, equipment, technology, and layout to ensure repairs are carried out efficiently, safely, and within budget. We adopted the repetitive focus process strategy, which is ideal for handling tasks that are routine yet critical. This approach resembles an assembly line where standardized operations are repeated consistently. Why this strategy? First, it ensures high quality control. In an airport setting, even minor errors can compromise passenger safety and cause major operational disruption. Standardized procedure minimize variability and ensure consistent result. Second, it allows for efficiency in modular tasks. Many of repair activities like changing standard components or running diagnostic can be broken into predictable steps. Repetition helps us optimize these processes. Third, we achieve a balance between structure and flexibility. While some repairs follow standard procedure, others may require adjustment. Repetitive strategy gives us a best structure with room to adapt when needed. We also gain resources optimization by using pre-manufactured parts and assigning technicians efficiently. We reduce waste and maximize productivity. Finally, this strategy is high scalable, meaning we can handle sudden increases in workload without slowing down. Next, we carefully selected equipment to meet both short-term repair demands and long-term maintenance needs. We will focus on market stability, where we choose equipment from reputable brands ensures that spare parts and technical support remain available in the future. Capacity is where the tools and machine must be capable of handling expected workload without causing bottleneck. For maintenance requirement, equipment that is low maintenance reduce downtime and keep operation running smoothly. For quality, we choose high standard tools proven in similar transport environment because the reliability of repair trends depends heavily on the tool use. And finally, cost efficiency. We balance initial investment costs with the equipment long-term value and operational savings to maintain a positive cash flow. Moving to technology employment, to enhance precision and speed, we're integrating several advanced technologies. RFID and automatic identification system help track components in real time, reduce manual data entry, and prevent mismatches or inventory errors. Vision systems are used for highly accurate inspection, making it easier to identify faults or ensure parts are fitted correctly, crucial for meeting safety standards. Automated storage and retrieval systems streamline inventory management by automatically organizing and retrieving parts. This saves time and reduces human error. Automated guided vehicles are used to transport heavy components across the facility safely and efficiently, reducing physical strain on workers and boosting workflow speed. A real-time process control system using sensors and monitoring devices allow supervisors to track repair progress and ensure all quality benchmarks are met in real time. The physical layout of repair area is just as important as the tools and strategy. We choose a hybrid layout combining work cell and fixed position model. This is for layout decision part. The work cell layout organizes the space into specialized zones for specific tasks, such as diagnostic, component replacement, and testing. This minimizes movement, saving time, and keeping operation focused. The fixed position layout is necessary because the aerotrains themselves are too large and complex to move easily. Instead, the equipment and technician go to train, not the other way around. These layouts support large-scale, space-intensive repairs like undercarriage work. This hybrid model allows us to get the efficiency of structured workflows with the practicality needed for handling large immobile systems like train. We're moving to layout design consideration. In designing this layout, we consider several critical factors. Space utilization. Airport facilities are often constrained. Our layout maximizes the use of available space without creating clutter or bottleneck. Flow of material information. Tool, parts, instructions must be readily accessible to minimize delays. Information boards and storage are placed strategically near work zone. Employee morale and safety is well designed. Layout reduce physical strength, enhance visibility, and includes clear safety signage. Comfortable, safe environment boosts morale and reduce accidents. Customer perception. While the public won't see much of the repair process, any visible areas should reflect MHB standards of professionalism, cleanliness, and efficiency. And lastly, flexibility. If the repair scope changes or new technology emerge, the layout must be easy to adapt with minimal downtime. In summary, our process strategy and layout decision for the MAHB Aerotrain repair project combines efficiency, safety, and flexibility. The repetitive focus strategy, carefully chosen equipment and technologies, and a smart hybrid layout design will help us deliver high quality results quickly and cost effectively.
Hello, my name is Mohamad Aiman bin Azman, metric number BK22110277. So I will talk about the maintenance and the reliability. So for the maintenance and the reliability parts, we propose to shifting from the reactive to preventive and predictive maintenance. We will use a computerized maintenance management system to schedule and track all the works orders efficiently. By applying this strategy, we aim to cut down time by 50%, which will save a lot on emergency repair costs. We also plan to improve the system reliability by increasing the mean time between the failures by 25% and reducing the repair time by 20%. To achieve this, we will integrate modern tools like IoT sensor, AI diagnostics, and the digital twins for the real-time monitoring. With a higher uptime, passengers will experience smoother service and KLIA's reputation will improve. For the continuous improvement, we will apply Kaizen, total productive maintenance, and root cause analysis techniques. So for our target is to maintain the 99% system availability in line with the international standards like ISO 5503. So for the next slide is about the capital budgeting. So for the capital budgeting, the total project budget is estimated at 30 million ringgits. Discover system repairs, component upgrades, safety enhancement, and staff trainings. We also include 10% contingencies reserve to handle any unexpected costs. Cash flow projections and earned value management will be used to control the budget throughout the project. We also consider the risks like cost overruns, supply chain delays, and compliance costs with strategies to mitigate them. Funding will come from MAHBs, internal reserve, government supports, and private partnerships. We expect to earn a return on investment within 3 to 5 years, mainly by reducing downtime and improving the operational efficiency. Finally, this budget plan supports KLIA's long-term goal of becoming a more reliable and world-class international airports.
The KLIA Aerotrain Certification Project is a critical initiative to restore safe, reliable, and efficient transit between terminal at KLIA. By combining strategic planning, risk management, stakeholder engagement, and modern technologies, the project aims to resolve long-standing mechanical failure while enhancing system reliability. Through structured workforce deployment, strict quality control, and sustainable practices, the project not only addresses current challenges but also strengthens public confidence and supports Malaysia's position as a leading global aviation hub.